Thank you very much again, Daniel. Thank you very much all for attending. Let me tell you a story about a Vine clone. And in order to do that, I'll spend just a minute telling you how I work at Gather on a daily basis. If any of you are interested on a fun solution for remote work, I invite you to check it out. I'm a side experimenter guy by night. This is where most of this stuff comes from, and soon to be a full-time father. I'm going to take a page out of Minter's book, and I'm going to do a product demo first. Then I'm going to discuss the architectures of the Thicket app, talk about the usage of CRDTs for the multiplayer async operations. This is not going to be in-depth as Hugo's talk or how Alex described CRDTs. So highly advise that you go for them for the specifics. This is just going to be a showcase for a proof of concept. Then I'm just going to talk about the takeaways, and if there's any room, we'll go over some Q&A. So product first. What I'm going to show you in a second is a video of Thicket. The idea behind Thicket is that you get communities. You're part of communities. Because this was built 5 years ago, there were, and as a research project, there were a bunch of difficult things that had to be put in place in order for it to work. So I had to take out some of the harder stuff. In retrospective, I wished UCAN was available back then. Definitely makes, or should make things easier for dApp builders nowadays. Because of that, identity was not built into this dApp. The approach took the idea of having unguessable URLs that would be shared amongst peers so that they would all be part of a community. Again, the idea, I'm going to record, you'll see how a GIF is recorded. We're going to post that GIF to the community. The link to the community is going to be shared amongst peers. And then whenever other peers visit that link, they're going to be syncing and, you know, fun and frolics when you get to share GIFs. So here's the Thicket UI. Basically, I created a community, then recorded a GIF. GIFs are fun. I highly suggest that you take a moment to do that and enjoy. This peer is adding some metadata to this GIF, and then it's posting the GIF to the community. Then what I'm doing here is copying the link, opening an incognito window, which triggers a different peer. This peer syncs with the community, the most up-to-date state, goes into the GIF, and updates the metadata associated to that GIF. This actually took me a second because I was having problems whilst I was doing that. But after a second, you can see how the original peer has the most up-to-date information. I'm going to take that peer offline, bring in Firefox, make sure that Firefox syncs. Then I'm going to post a GIF using this other client. And then after that, you're going to see Firefox is going to do some updates to the existing GIFs. And then I'm going to take Firefox offline, bring back the original peer, and you'll see how the original peer gets the most up-to-date state. And this is happening because of the magic of CRDTs. As a consideration, we also post the size each community takes up on your computer so that you know how many resources you're giving back to the community. That was the whole idea behind calling these communities. How there were different layers put in place. Not the simplest, but that layer I'm not going to touch on is the UI. Building UIs, building buttons, definitely fun, definitely suggest that you do that. But the thing I'm going to be focusing mostly here is the other two layers. A layer which I never understood as a backend, but there was this misinterpretation or misconception of decentralized meaning no backend. That's not the case. If anything, earlier today I was referring to IPFS as a distributed or shared file system. Thank you very much, Daniel, for correcting me. That's not the case. IPFS, and this would be one of the key takeaways for me whilst building a DApp on top of IPFS, it's a content addressable transfer protocol. I've already proposed that name change, but no traction so far. And so in reality, the DApp connects to this node, which would be that backend layer. And then via the pops-up mechanisms that come with IPFS, we get the multiplayer effect. In a diagram type of way, what Thicket does, you get a swarm of peers connected to each other, which are posting via the pops-up mechanism to everybody connected on the same topic. And then we get the most up-to-date state in your store via the magic of this flux pattern. You get the rendered state in your UI. And just as a small description of what the Thicket state looks like, there is a list of publications. Each publication has a metadata associated to it. Each community has a metadata associated to it. And then each peer can also have nicknames. What do CRDTs do for Thicket? Because we have multiplayers, we have asynchronous operations happening at different times, we need a way to make sure that every peer, when they connect, has the same data structure and is up to date with all of the operations that have happened within this data structure. And the CRDT, this is the magic that CRDT did for Thicket. It normalized all of this data whenever this operation happened at asynchronous times. That's why the demo showed you how two online peers shared real-time information, but when one peer went offline, operations continued happening, and when that peer came back online, the peer had to sync. And that's one of the other things that was a mind shift for me. When working with IPFS and a real-time pops-up mechanism, you're not really loading data from a backend. You're mostly syncing with all of the operations happening with all the connected peers. I'm just going to go over very quickly over the most important pieces of code here. You definitely need an instance of IPFS. Thicket, 5 years ago, what I was doing, I was running a full node in the browser. Highly discouraged that you do that. Way better if you connect to your local node or some node that you can offer. This was done using the experimental pops-up flag, and I tried to keep it very lean. I removed all of the bootstrap nodes and made sure that Thicket connected to a publicly available node so that the network layer would work for Thicket. This is a code that needs the IPFS instance. I'll be using that throughout the rest of the code. And then for CRDTs, I was using a library called YAS. Very handy utility, works almost out of the box with IPFS. The way you use YAS, you extend it depending the different resources that you're interested in. And whenever you instance, whenever you need an instance of YAS, you have to send over pass the parameter of your IPFS node and several other parameters. The decision was made for Thicket that each community would get its own independent pops-up room so that you wouldn't get noise in the boss. And then CRUD operations. The way that Thicket posts images to the node is using the existing API for adding files. Whenever you get the response from that, you grab the hash, and then you publish that via your shared instance in your via your shared state in your Y instance. And because there's metadata associated to each hash, you also publish that. When you're reading information, you need to get a hold of the hash or hashes. You enumerate that by using your shared data structure. Whenever you have the hash, you can get the metadata, and then you can cut the images data directly from your node instance. I perform a small transformation so that this could be used in an image element. Update operations, basically what we're dealing here is a JavaScript map object. So you're doing set and get operations. So whenever you update, this was making sure that the rest of the information was there, and you just updated the piece of information that you needed, and delete operations. Once you have the get hold of the hash, you delete the publications, and as a side effect, you delete the metadata. And this is where the magic is happening. Every shared data structure within the Y instance is something that you can observe, that you subscribe to. Whenever there are changes, whenever a peer comes in and syncs, you might get changes. And you can, in case you're interested, see the type of change, because if there might be side effects to some of the changes if this is a delete. Similarly, you listen in to via the Y instance to whenever users join. And you have to wait for this specific event when synced to know when to perform your operations. Like, hey, this other node came online, their operations have been synced, now I need to perform side effects, like updating nicknames. Or if you've already subscribed, your changes should be propagated to your store, which then should propagate to your UI. I know that was intense, I know that was fast. It was fun. I hope I haven't lost you guys. Key discoveries whilst building Thicket 5 years ago. I remember the JS IPFS README had a legend, beware of the dragons. There were dragons. We've been joking around that maybe some of those dragons have not been slain, but maybe they've left the premises, who knows. Back then, we ran into very, very weird situations. There was a Aegir build process, which was an in-house thing, which wasn't playing nice with the Create React app. So we had to figure out a bunch of ways to put everything together. When we were able to build something and put it online, things weren't working. And so that's when I started looking at why aren't nodes connecting to each other? And that's when I realized, hey, we're trying to connect using these bootstrap nodes given to us by IPFS. What happens if instead of relying on those, because they do not seem reliable enough, I use my own node? So that's when I started understanding the problems at the network layer. And as I mentioned earlier, definitely did not even try to deal with the problems of identity and security. This was mostly a proof of concept to see if we could have a social sharing application for GIFs using IPFS, which was successful and was very fun. There was a bunch of documentation done back then that I published. If you're interested, not sure if these slides are going to be made public. If not, come and find me. I can share a link with them to you all if you're interested. And yeah, if there are any questions, that was it.